You'll notice this is 7.8. So this is going to be talking about reaction yields and something called limiting and excess reagents. So you're going to be practicing the process we just talked about here quite a bit more in this section. So that's why there's not more practices yet. You're about to have some good practices. So if you ever gone to make a batch of cookies or something and you notice that you're out of an important ingredient, well, not completely out, you got like half what you need. So what you do is you half all the ingredients. You know that you can't put in, half the amount of flour and the full amount of all the other ingredients and get cookies that turn out any good. That's the idea behind chemistry, behind any reactions, is you need to have the right amounts. So if you've got a lot of guys in play in these reactions, like you do when you're making food, you have to have enough of all the components to get the reaction to happen. So here's what we're doing. We've got our sulfurs are being squares in this picture. So this is our visual. And then our oxygens are being circles. And notice that they're kind of stuck together. That's because it's diatomic and it's got the 2 there. So we're drawing this reaction. Notice we have 2, so we have 2 squares, 1, 2 squares. And notice we have 3 of these guys. So, there's 1, 2, 3 sets of those. Now, how many of these do you end up with? So you'll notice you have your squares, that's your S's, and the O's are attached to it. So it has an O, O, and O. So I've used up an O, and one of these O's, and one of my S's. And you'll notice what I have left over is 3 more of my O's. There's the picture showing you this is a perfect reaction. Most of the time you have a little extra of something. And then what you have extra of is usually the cheaper ingredient in real life chemistry. Or it's the easiest to handle ingredient. That's what you have extra of. So now we've got another mixture. Still we have our S's. So these are our squares. And then our O's. This is better because it shows the O's being, a different color. So now what you're trying to figure out is how many, we're doing the same reaction, how many can you make of the SO3s? So it's the same reaction. So one of these pictures matches it. So pause the video and decide which you think is the answer. So if you'll notice, this left picture is showing S2O6 in both cases. That's not what we're trying to make. We're trying to make SO3. This picture is showing S2O3. That's also not what we're trying to make. And again, this one shows the S2O6. That's not what we're trying to make. It's not this, this, or this. Now, the right 2 pictures are showing everything that we're trying to make. Notice that both D and E both have all of our squares being used up. 1, 2, 3, 4, 5, 6. And they both have the 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the question is about our oxygens. How are they doing? So how many do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 of them. 12 single O's available. Which one shows the 12? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That one looks right. If you go to this one over here and you start trying to count them, you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this one does not work. This one has too many O's. There's something important that this picture is telling you. It's telling you that one of the reactants limits the reaction. It limits how many things can be made. Is it the squares that's limiting, or is it the oxygen? Which one did we run out of? So you ran out of the oxygens, the circles. That is what limited our reaction. You had extra of the sulfurs. Those are the squares. and that is our excess. Kind of getting the sense a little bit of this. So here's another picture just to make sure you've got this idea. So you're going to draw a picture to represent 4 moles of CO. And again, we're keeping the O's being circles. And on the right, you're going to show how many CO2s. So again, what the reaction we're saying that we're doing is 4 COs plus 6 O2s. And we're going to see how many CO2s that you end up with. So pause the video. So at this point, we've got our carbons in there, and I'm putting the oxygens. So there's 2 oxygens in all the carbons. So I'm going to see if I have enough oxygens to do this. So I put all my carbons in. So I've used up 1, 2, 3, 4, 5, 6, 7, 8. So I've used up 8 oxygens. How many did I have? 4, 6, 8, 10, 12, 14, 16. I had 16 oxygens, but I've run out of carbons. So it just means that I've still got extra oxygens in this. So I've got extra unreacted oxygens. All of these guys are unreacted. So I had extra oxygen, and I'm limited by my carbon. Or aren't they both used up? Well, you have extra of 1. You can't make any more CO2s if you're out of C's. This picture is what happens in most chemical reactions. Probably they chose the oxygen because it's an abundance, and carbon monoxide is not so great to work with, right, as humans. So probably they limited the carbon monoxide, and they just put lots of oxygen in there.